ఒకటి వస్తుంది, ఒకటి రావడం లేదు. నిన్నట్లాగే సేమ్ సరిగ్గా ఇవ్వడం లేదు లింక్స్ వాళ్ళు. దిస్ వీడియో ప్రైవేట్ అని వస్తుంది. Yeah, I'm live only in one channel. Second channel I am not getting. That's what I'm saying. The television channel, it is not telecasting. Why this problem every day? Shall I continue my class in this channel? And that too, it has gone into yesterday's channel, yesterday's. So it is showing that 23 hours before. This is showing that same engineering hydrology application of unit hydrograph. In this different topic, it is showing a different place. So there is a technical glitch, I think. Better you sort it out. Every day it is happening to me. Send me proper keys. I am not live on both channels. I have to see now. I have got cross check here. So it is showing private. Nothing is coming there. I am cross checking. And that too, it has gone into yesterday's channel. It is telecasting in yesterday's slot. Where is I am live in both channels? No. You can see me here. If I press it, it's going into private. Okay. Anyway, what to do? That's your problem. That's what I am saying. Giving same key every day, and again you are saying me that I'll change the title. So you are making fool of me. So same topic, how students attend, student watch this content. And at the end of the month, then you will say that views are not there. Then you will cut my salary. Isn't it? Who will watch me in the old topic? Already they saw it already. I'm teaching new thing here. Now you are saying that I'm changing the title. What kind of thing it is? What's going on here? I don't know. Whatever you do, it's my job only. Okay. So yesterday we solved one problem, how we can construct the T hour unit hydrograph from the given D hour unit hydrograph. So from the D hour stamp, how to travel from D hour stamp to T hour stamp. We saw yesterday, right? From the given D hour stamp to how to travel from D hour stamp to T hour stamp. Okay. So we discussed there are two methods. One is method of superposition. Yesterday we discussed about that method. And second method is S-curve method. This S-curve method is toughest among all methods. So let us see one more question related to method of superposition so that you become comfortable in this method. So once you are familiar, comfortable with this method, then we go ahead with the S-curve method. Okay. So let us solve one more example related to this method. This is also a GATE question. Of course. Okay. Question goes like this. Ordinates of 1 hour, unit hydrograph at 1 hour time intervals. Or 1 hour time interval starting from time t0. Zero, 5, 8, 3, 1 and 0 meter cube per second. Construct 3 hour unit hydrograph and find the P coordinate of 3 hour unit hydrograph. Or otherwise they will give you what is the P coordinate of 3 hour unit hydrograph. Okay, this question has been asked to you. So now how to approach. Solution to this question. So what is given is D. D hour unit hydrograph is given to you. From this we are working out T hour unit hydrograph. Okay. One hour unit hydrograph is given. What I have to find out is 3 hour unit hydrograph. Therefore, D is equal to 1 hour, capital T is equal to 3 hours. So first of all, we have to verify with the conditions whether it satisfies the given conditions or not. What is condition 1? So first condition is T should be greater than D. So T is 3, D is 1, satisfy that condition. And N is equal to T by D. So T by D if you take, it is 3. So it is a real integer. So T is equal to NT condition also satisfied. Therefore, superposition is valid. We can comfortably apply superposition method. And what you need to do, this 3 hours term you have to split into, right, 3 terms, n number of terms. This is first term, this is second term, third term, something like 0 to 1 first term, 1 to 2 hour second term, 2 to 3 hour third term. Actually it is a single term of 3 hour duration. This term of 3 hour duration, single isolated term of 3 hour duration. For our comfort and convenience, we broke this term into 3 terms, each of 1 hour duration. This is first storm. This is second storm. This is third storm. For each 1 hour storm, 1 hour hydrograph. For this 1 hour unit hydrograph is available. For this also 1 hour unit hydrograph is available. For this also 1 hour unit hydrograph is available. Start at 0, end at where? At which time interval it end? 0, 1, 2, 3, 4, 1 hour time intervals, no? 0, 1, 2, 3, 4, 5. 0, 1, 1, 2, time interval 0, 1, 2, 3, 4, 5. 5 ordinates are there. Okay? So therefore, it ended at 5th hour. 0 hour, 1 hour, 2 hour, 3 hour, like that ordinates are given. 0, 1, 2. Second hour maximum, no, it is. Okay. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. These ordinates are given. These ordinates are, what are the ordinates given there? 0, 5, 8, 3, 1, 0. 0, 5, 8, 3, 1, 0. So 0, 5, 8, 3, 1, 0. Okay, it is 3. Okay, this one is 3. Third hour it is 3. So little bit it is 0, 5, 8, 3, 1, 0. 0, 5, 8, 3, 1, 0. Then if you draw the hydrograph for this, it could be like this. Okay? It is like this. I'm roughly plotting the hydrograph. Okay? It's not correct. Understood, no? So this is 3 here. This is 3. This is 1, 0. Hope you got it, I think. These are the ordinates at 1 hour time interval. This is 1 hour unit hydrograph. Similarly, one more 1 hour unit hydrograph. Start where? Exactly somewhere here. And one more hydrograph start somewhere here. The first hydrograph started to 0 hour. Second hydrograph started to same hydrograph. Third hydrograph started second hour. So again 0, 5, 8, 0. This is 5, 8, 3, 1, 0. Okay? 0, 1, 2, 3, 4, 5, 6. Similarly, this is 0, 1, 2. 0 start at 2. Then again, it is 5, 8, 3, 1, 0. 0, 2, 3, 4, 5, 6, 7. So like this, all these three if you combine together, you will get one direct runoff hydrograph. This represent 1 centimeter runoff. This represent 1 centimeter runoff. This represent 1 centimeter runoff. This is 1 hour delayed, 1 hour unit hydrograph. This is 2 hour delayed, 1 hour unit hydrograph. If you combine all these three things into one, you will get one direct runoff hydrograph representing runoff total 3 centimeters. So for 3 centimeters, you will get direct runoff hydrograph. If you divide by 3, then you will get unit hydrograph for T hour storm. That's what we need to do. So let us work out mathematically this one. How we can proceed mathematically? Let us see. So this is time. This is for first storm, second storm, third storm, all three storms together it is, then finally unit hydrograph will get. That's it, there in methods. So it is time. This is 1 hour unit hydrograph ordinates. This is 1 hour delayed. This is for first storm, sorry, I need to write that. First storm is not delayed, it is right on time. For first storm, 1 hour unit hydrograph ordinates. This is second storm. Second storm, how many hours delayed? It is 1 hour delayed. 1 hour delayed, 1 hour unit hydrograph ordinates. This is for third storm. Third storm, how many hours delayed? 2 hour delayed, 1 hour unit hydrograph ordinates. So all this, if you combine together, you will get one direct runoff hydrograph, T hour direct runoff hydrograph ordinates, representing a runoff R is equal to 3 centimeters. That is first storm, second storm ordinates and third storm ordinates. If you combine, then you will get this in so and so meter cube per second. The last, then you will get T hour unit hydrograph ordinate. So that's what is called construction. Construction means finding. Which is equal to T hour direct runoff hydrograph ordinates by runoff R. So R is equal to what? 3 centimeters. So different time intervals ordinates are given 0, 1, 2, 3, 4, 5. 0, 5, 8, 3, 1, 0. These are the ordinates given in the question. Question only given 0, 5, 8, 3, 1, 0. Right? Then second storm, 1 hour delayed. 0 should come at 1. The remaining ordinates post in the same order. 5, 8, 0, 5, 8, 3, 1, 0. So one more extra ordinate you got at 6th hour. This is 2 hour delayed. So 0 should come exactly at second hour. 0, 5, 8, 3, 1, 0. So 7th hour. You can see there diagrammatically I represented here. It started second hour, ended to 7th hour. It started first hour, ended 6th hour. Second storm. First storm started 0 hour runoff, ended 5th hour. So they started first hour, ended 6th hour. They started second hour, ended 7th hour. So up to 7th hour we have got ordinates. See now, first storm started 0, ended to 5th hour. Second storm started to 1, ended 6th hour. Third storm started to second hour, ended to 7th hour. Runoff contribution. So if you combine all these three things into one, this is 0, 5, 13. So 8 plus 3, 11 plus 5, 16, 12, 4, 1, 0. Then what are the ordinates for T hour unit hydrograph? T hour means what? 3. T is equal to here 3. 3 hour unit hydrograph this is. This is 3 hour direct runoff hydrograph. This is 3 hour direct runoff hydrograph. Then this is 3 hour unit hydrograph ordinates. So 3 hour unit hydrograph ordinates is equal to 3 hour direct runoff hydrograph ordinates by R. So 0, it is 5 by 3, it is 13 by 3, 16 by 3, 4, 4 by 3, 1 by 3 and 0. So what is the P coordinate he is asking? What is the P coordinate? Among all these, 16 by 3 is the maximum ordinate. So 5. That was the question. Answer for this question. So answer for this question is what? 16 by 3 meter cube per second. So P coordinate of 3-hour unit. This is construction. This is a curve. The construction is over. Therefore, P coordinate of 3-hour unit hydrograph is equal to, it is 16/3 meter cube per second. That was the answer for this question. So that is how you have to work out questions. Hope it is clear to you now. Shall we take one GATE question? This is also GATE question. This question is asked in GATE. I think this is a GATE question. This question is being asked in the year it is GATE 2011 question. This is GATE 2011 question. Excuse me, 1 minute. నేను చూస్తాను తెచ్చిపెట్టాను నేను ఎక్కడ ఉంది రెడీ Okay, whether it telecast or not, no problem for me. My job is only to teach. So let us take one more question. GATE, this is GATE 2011 question. Let us try one more question. GATE 2003, this is a very good question. If you solve this question, then things will be very clear to you. during a period of 12 hours. With a uniform intensity. He has given like this, the unit hydrograph. Question is, options are given. 150 Qmax. Of course, he mentioned it as Qmax. Qmax means meter cube per second only. Whichever way he has given, I'm trying to give same way. B 225 Qmax. Also not. ఏమి ఇచ్చారు కామెంట్స్ బొంగాడు పడ్డారు ఇచ్చారా కింగ్ ఆఫ్ చూపించు D360 Qmax. There is one question. First question. Second question, area of catchment in hectares is. And you have been asked to find out area of catchment. Come on, let us try this problem. This is a challenging question, okay? If you solve this question, single question, then I understood that you got expertise in working out problems related to superposition. So what is given is, question first of all, try to understand. So first you try to understand. there is a 12-hour storm occurring in a catchment, but what is given to you is 6-hour unit hydrograph. 6-hour unit hydrograph is given to you, and something related to 12-hour storm you have been asked to find out. Then how to work out 6-hour unit hydrograph, you have to convert it to 12-hour unit hydrograph. Then anything related to 12-hour storm you can find out. Come on, I have given hint to you. Come on, work out. So what is given is, he has given information related to 12-hour storm. So there is a 12-hour rainfall in a catchment. Okay, that's what mentioned. 12-hour rainfall with uniform rainfall. Uniform storm it is. So uniform storm producing how much amount of rainfall? P is equal to uniform storm, P is equal to P, T is equal to T. This is 12 hours, and this is producing how much amount of rain? 16 centimeter rainfall, 16 centimeter. So P is equal to how much it is? 16 centimeter. And pi index for this catchment also given to you. Pi index for this catchment is given as how much it is? Pi index of this catchment is 0.5 centimeter per hour. So that is also given to you. Okay. So for this term you need to work out. What you need to work out? Peak discharge of the direct runoff hydrograph. That means for this term you have to find out peak discharge of the direct runoff hydrograph. So peak coordinate of direct runoff hydrograph for this term. Peak discharge of the resulting direct runoff hydrograph. Indirectly, what you have been asked to find out? Peak coordinate of 12-hour direct runoff hydrograph. That was the question. But what is given to you? A 6-hour unit hydrograph is given. Okay, let us work out. So I have started at wrong place, okay? Kindly. So what is given to you is a 6-hour unit hydrograph. It is linearly increasing. That means indirectly mentioned that it is a triangular shaped hydrograph. Linearly increasing 0 to 30 in the first 6 hours and 30 to 0 in the next 12 hours. She has given like this. This is 6-hour unit hydrograph given in the question. Ma class lo unna. Class lo unna ma. Bye. Okay? But ordinates and all not given to you. Okay? Ordinates and all not given, but we have to generate because it is a linear, we can generate. So these ordinates also you can generate at any time interval. But what I need, 12-hour unit hydrograph. 2 6-hour unit hydrograph, if I combine like this, I'll get one 12-hour direct runoff hydrograph. This is 0 to 18. 0 to 6, 6 to next 12 hours, it is linearly decreasing from 30 to 0. That's what is given in the question. Okay? So that means triangle. If you have combined these two things, I'll get one 12-hour direct runoff hydrograph, something like this. That I have to find out. So for this, from this I have to derive one unit hydrograph, 12-hour unit hydrograph. Once we get unit hydrograph, then I can work it out. So for this also, you have options. So you can generate ordinates at any point of time. So ordinates at any time interval you can generate. But let us go with minimum ordinates. Minimum ordinates you get, if you generate at time intervals as 0, 6, 6, every 1 hour also you can generate. Every 2 hour also you can generate. Right? So when you generate ordinates, they should be in such a way that you need one extra ordinate at 6th hour. So like this 6th hour it required. Every 1 hour you generate ordinates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18 ordinates will get. So first hydrograph you can start here, second hydrograph you can start at 6th hour. Every 2 hours you can generate 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. So first hydrograph you can start here, second hydrograph you can start here. Every 3 hours also you can generate 0, 3, 6, 9, 12, 15, 18. So first hydrograph you can start here, second hydrograph you can start here. 4 hours ruled out because it doesn't facilitate superposition. Therefore, it is ruled out. 5 hours ruled out because 6th hour ordinate is not there. So every 6 hours also you can generate 12, 18. This is also okay. First hydrograph started here, second hydrograph started. So you have got 4 options. Every 1 hour you can generate, every 2 hour you can generate, every 3 hour you can generate, every 6 hour you can generate. So whatever maybe the time interval, no issue, your answer would be same. So let us go with minimum ordinates. Which will give minimum ordinates? 6 hour time interval will give minimum ordinates because it's a gate question. So therefore time saving in time also important for us. Therefore let us generate ordinates at every 6 hour time interval. So 0 hour it is 0. The ordinate is 0. At 0 hour it is 0 anyway, given there. In the question only it is given. 0 hour 0. Then 6th hour 30. Then I need to generate one more ordinate exactly at 12th hour. If I generate one more ordinate exactly at 12th hour, job done, it is. Almost finished. Okay? So only one ordinate are generated. By using similar triangle concept, I can work out. This is 30 for a distance how much here from here to here 12. For every 1 hour, so rise is 30 by 12. For every 6 hours rise is 30 by 12 into 6. So it is 15 meter cube per second. So I got ordinates 0, 30, 15, 0. I got ordinates at every 6 hour time interval. So this is 6 hour unit hydrograph with ordinates 0 hour 0, 6th hour 30, 12th hour 15, 18th hour it is 0. This is 6 hour unit hydrograph ordinates I got. So now let us work out this problem. So the 12 hours term we can divide into two 6 hours terms. 12 hours term we can divide into two 6 hours terms. This is first term, this is second term. 0 to 6 one term, 6 to 12 another term. So first term, this one is second term. Okay, then what else is given? So let us first generate the 12-hour unit hydrograph. So to generate the 12-hour unit hydrograph, let us superimpose and work out. Superposition is valid or not in this question? So here D is equal to 6 hour, because 6 hour unit hydrograph is given in the question, that is taken as D. But to generate something related to 12 hours term, so we require 12-hour unit hydrograph. This you have to generate. Therefore T is equal to 12. So T is greater than D. N is equal to T by D. So it is 12 by 6. It is 2. So it satisfied second condition also. Therefore superposition is valid. Superposition is comfortably you can apply, valid. Then let us work out this problem by using table. Okay. So what actually is looking for? Is looking for only the P coordinate. So just we are looking for P coordinate. Let us work out that P coordinate. This is time. Once you understand the concept, it is so simple and so easy. This for first term. This for second term. This for both of these terms together. This for both of these terms together. This for unit hydrograph. Okay. So it is time. Time in hours. Okay, this is too mild. This is for first term. 6 hour unit hydrograph ordinates. This is for second term. How many hours delayed? 6 hours delayed. 6 hours delayed, 6 hour unit hydrograph ordinates. Two terms together what will get? 12 hour direct runoff hydrograph ordinates, representing a runoff of how much? 2 centimeters. Because first term 1 centimeter, second term 1 centimeter, both of them together known as 2 centimeters. Each term 1 centimeter. Unit hydrographs, no, that's why. Then what you require? 12 hour unit hydrograph. He is not asking for this term. The real storm which is occurring in a catchment that is producing different amount of runoff. For that runoff we need to work out. So therefore, here it is not the answer. So from this table you don't get answer. So it is 12 hour unit hydrograph ordinates is equal to, it is 12 hour direct runoff hydrograph ordinates by 2. This also will get in meter cube per second. So ordinate just we generated 0 hour, 6 hour, 12 hour, 18 hour. Every 6 hour time interval you have generated one ordinate. 0, this is 30, this is 15, 0. Second one 6 hour delayed, 0, 30, 15, 0. So one more ordinate extra you got at 24th hour. Okay, both of them together 0, 30 plus 0, 30, this 45, this is 15, 0. If we divide by 2, this is 0, 15, this is 22.5, this is 7.5, this is 0. What is the P coordinate here? The P coordinate of this one is this one. So therefore P coordinate of 12-hour unit hydrograph is equal to P coordinate of 12-hour unit hydrograph is equal to, it is 22.5 meter cube per second. Now let us see how to find out this one. What is per real storm is asking. Real storm producing how much amount of runoff? So pi index is given to you. Pi index is equal to, it is P minus R by T. Real storm occurring for 12 hours producing a rainfall of 16 centimeter, where pi index is 0.5. 16 minus R by 12. So real storm producing a runoff of how much it is? 16 minus 6, it is 10 centimeter. So therefore P coordinate of 12-hour direct runoff hydrograph is equal to, it is P coordinate of 12-hour unit hydrograph into runoff R. Real storm producing this much. So how much we got? 22.5 into 10. So it is 225 meter cube per second. That was the answer for first question. First question only tough part it is. Second part is easy. So you can see the options. What options are given there? Options matching or not? Yesterday's it is. So what options are given? 225 is there or not? So this 225 is matching. So therefore this is the answer for that question. So we got 225 only now. We have got 225 answer. Real storm producing 16 centimeter rain for 12 hours. Pi index is 0.5. Therefore runoff produced by real storm is 10 centimeter. For that 10 centimeter peak discharge of the resulting direct runoff hydrograph. That is 225 meter cube per second. That's what we got. Second question, area of catchment. So let us work out area of catchment now. So catchment area, that is so simple and so easy, easily you can work out. So that is not a big problem. So catchment area is equal to area under 12-hour unit hydrograph, or 6-hour unit hydrograph also you can use, because all these hydrographs represent same catchment. You can use 6-hour unit hydrograph also. Area under 6-hour unit hydrograph also you can use. Is it triangular now? So it is half into. Now this is a volume of runoff by depth of runoff actually. So volume of runoff by depth of runoff. Since we are using unit hydrograph, depth of runoff is 1 centimeter. If you divide by 10 power 4, straight away will get answer in hectares. So one say hectares. Kilometer square means 10 power 6, hectares means 10 power 4. So it is half into 30 into base is 18 hours, 60 into 60. Triangular, no, it is shape. Shape is triangular. This is 6-hour unit hydrograph. Shape is triangular with a peak discharge of 30 and base of 18 hours. Understood? From this we got this one. By depth of runoff is 1 centimeter, because it represents 1 centimeter runoff, which is equal to 1 by 100 meters. So meter cube by meter, meter square will get, to convert meter square into hectares, by 10 power 4. That's it. That was the answer for that question. Come on, work out now. So 0.5 into 30 into 18 into 60 into 60 into 100 by 10 power 4. So it is 9,720 hectares. That was the answer for second question. So let us see the options that is given or not in options. So 9,720. So this is the right answer. So this is how we can work out the questions. Understood now? between we left so many slides. $9,720. Okay, I hope it is clear to you. Then once you are comfortable regarding this concept, then I can go ahead with S-curve method, summation curve method. So let us see summation curve method. So toughest among all topics in hydrology is S-curve only. Of course, superposition you are comfortable, S-curve method also you can work out. Shortcut we write as S-curve method. Okay. To understand this concept, so it is highly hypothetical and imaginary concept. Okay, there is no reality in that, but the beauty of this concept is with the help of this hypothetical concept we try to realize the physical reality. That's why this technique is very, very popular. So we can arrive at physical reality with the help of this one. So finally, what is required? Forecasting the floods. That's important for us, right? So we can comfortably forecast the things using this. So that's why it is very, very popular. So that's why it is very, very popular. Okay. So S-curve also a hydrograph. Anything discharge versus time plot is known as a hydrograph. So there is a catchment which receive. Assume this is a catchment, okay? So this is a catchment. This catchment drain flow into stream. Assume it is a catchment. Okay, this catchment receive a rainfall of intensity. This receive a rainfall. Uniform storm. And duration of storm is infinity. So this catchment receive a infinite duration storm with effective rainfall intensity 1 centimeter per hour or 1 by d centimeter. Effective rainfall intensity is 1 by d centimeter per hour. How long this receive rainfall? Infinite time period. So first what happens, some of this rainwater get into ground due to infiltration. So infiltration loss occur in the beginning. So once infiltration ground is completely meet the soil moisture deficiency, okay, okay, area A kilometer square receive rainfall. So in the beginning what is there? Infiltration loss is there. After meeting the infiltration loss, so remaining rainwater flow above the ground and join groundwater table, join the streams. This is a ground. So remaining water flow above the ground as a runoff, okay, and joins the water body. This is runoff. This ultimately joins the water body. This is a stream or a river. So this is start discharging, constant amount of discharge known as Q equilibrium discharge. Okay. For such storm, because it is occurring infinite time period, what happens is after some time, after meeting the catchment losses, the catchment start draining constant amount of runoff. Stream also attain a constant discharge known as equilibrium discharge. Equilibrium discharge is a constant discharge. This is a constant discharge. Stream start attaining a constant discharge known as equilibrium discharge. For such storm, if we make a plot, if we measure discharge versus time plot, so the hydrograph that what we obtain is known as S-curve hydrograph. For this storm, if you make a discharge versus time plot, okay, the hydrograph which we obtained is known as S-curve hydrograph. This is also discharge versus time plot. This is known as S-curve hydrograph. Okay. The thing what you need to remember is this technique you can apply for catchments whose for catchments receiving rainfall whose duration is less than the given duration or more than the given duration. So this technique is applicable for storms this method is used to derive T-hour unit hydrograph from the given D-hour unit hydrograph, that is without any precondition. Whereas superposition to apply, it has to satisfy that condition, that is T greater than D or T less than D, you can apply this method. T is equal to ND or T is not equal to ND also, you can apply this method. That is the meaning of that, without any precondition. Okay, that point you have to remember. This method you can apply without any precondition. T greater than D or T less than D, you can comfortably apply this concept. Okay, let us see now. That is the thing. First of all, you need to know. So, a catchment of area a kilometer square when it receive a storm of infinite duration with a effective rainfall intensity (1 by the centimeter per hour). After meeting catchment losses, that is infiltration loss. Catchment drain, constant amount of runoff into a stream. Constant amount of runoff into stream. Then stream accumulate and attain a constant discharge known as equilibrium discharge. For such storm, if stream flow variation is measured with respect to time and when it is plotted, the hydrograph obtained is known as S-curve hydrograph. For such storm, if stream flow variation is measured at a point in a stream and when it is plotted with respect to time, the hydrograph obtained is known as the diagram explanation I wrote here, S-curve hydrograph. So in S-curve hydrograph, the very popular component is the equilibrium discharge of S-curve. S-curve hydrograph. That is the meaning of S-curve hydrograph. For this diagram, I have explained you what is this. Catchment is receiving. This is a catchment. So this catchment is receiving what? Storm of infinite duration. This catchment of area a kilometer square receiving a rainfall of infinite duration with effective rainfall intensity 1 by d centimeter per hour. After meeting the catchment losses, catchment start draining, constant amount of runoff into stream. Stream attain a constant discharge known as equilibrium discharge. For such storm, if you make a stream flow variation with respect to time, the hydrograph obtained is known as S-curve hydrograph. So what is the difference between S-curve hydrograph? Normal hydrograph represents storm of finite duration. S-curve hydrograph represents storm of infinite duration. So normal hydrograph, if you see, so they'll rise because they represent storm of definite duration. They rise and fall. So they represent storm of certain duration, d hour duration, with effective rainfall intensity 1 by d centimeter per hour. This is normal hydrograph, and unit hydrograph or normal. But whereas S-curve hydrograph represent storm of infinite duration. So there is only beginning, there is no end. In reality, you don't find such storm anywhere in the world. This is a storm of d hour duration. This represents storm of infinite duration. So it only rises and remain with that value forever, indefinitely. Okay? This represents a storm of what? Infinite duration. So there is no end, there is only beginning. Infinite duration storm. Effective rainfall intensity is same. This is hydrograph for definite duration storm. definite duration storm. This one is hydrograph for infinite duration storm. There is only beginning, no end. Reality, nowhere you will find such storm. It is only imaginary concept. Understood? So this infinite duration storm, for definite duration storm you have got only peak discharge. But infinite duration storm also you have got peak discharge. That peak discharge, what you get is known as equilibrium discharge. This is also peak discharge only, which is nothing but Q equilibrium. Once it attains peak discharge, it remains with that discharge indefinitely. So in the beginning only, it varies. So once catchment losses are completely fulfilled, then catchment start draining constant amount of runoff, it attains equilibrium discharge. So it rises and again fall. Definite duration storms. Infinite duration storm, it rises and remains there only. It doesn't fall again. It reaches the peak and remain with that peak indefinitely. That's the difference between definite duration storm and infinite duration storm. So it's an imaginary concept because there is nowhere in the world you'll find a storm occurring in a catchment for infinite time period. It is an imaginary concept, imaginary hypothetical concept. Okay, the very popular question related to this S-curve hydrograph is finding equilibrium discharge. So equilibrium discharge of S-curve. Then let us see how to work out equilibrium discharge of S-curve. This itself is a very popular question in competitive exam. How to find out Q equilibrium? Okay. So, how to get it? There is an equation to find out Q equilibrium. The Q equilibrium of S-curve we can find out by using equation 2.778 into A by D. 2.778 into A by D formula if you use, you can find out equilibrium discharge of S-curve. So in this equation, substitute A, catchment area in kilometers square. A is catchment area in kilometers square. D is the duration of definite duration storm, D hour unit hydrograph. So this is storm duration of D hour unit hydrograph, which is used to derive S-curve. So to derive S-curve, what we require? We badly need one D hour unit hydrograph. The D hour unit hydrograph only has got, right, D hour unit hydrograph badly required. With the help of this D hour unit hydrograph, right, we derive S-curve. So this D hour unit hydrograph only having effective rainfall intensity 1 by D. That's the meaning. So D hour unit hydrograph we use. So duration of that D hour unit hydrograph is taken in this equation to derive that value, equilibrium discharge. That means what? So the purpose for which we are using D hour unit hydrograph is, that is, runoff accumulate in a catchment once in every D hours is equal to runoff accumulate in a catchment, depth of runoff, that is, accumulate in a catchment once in every D hours is equal to how much runoff accumulate in a catchment once in every D hours? Effective rainfall intensity into time. Intensity into time will give depth of runoff. Effective rainfall intensity of the storm into time. So this 1 by D centimeter per hour into D hours. So it is 1 centimeter. Okay. Volume of runoff delivered into stream from catchment. Delivered or discharged into stream from catchment once in every D hours is equal to, it is depth of runoff into area of catchment. Depth of runoff into catchment area. So depth of runoff is 1 centimeter, right? Catchment area is what? A kilometer square. It is 1 centimeter into A kilometer square. Okay? Therefore, discharge accumulate in the stream. Discharge accumulate in the stream once in every d hours is equal to, so volume of runoff delivered by time. Volume of runoff delivered into stream by time. Volume of runoff delivered is equal to what? 1 into A, time is equal to d hours. This is only Q equilibrium. Therefore, Q equilibrium is equal to, what is the equation? Q equilibrium is equal to, it is 1 into A by D. So, this 1 is in centimeter, A is in kilometer square, D is in hours. But we are supposed to convert this into meter cube per second. So, to convert A into meter cube per meter square, what we do? We multiply with 10 power 6. Then this become kilometer square into meter square. Kilometer square become into meter square. Right? 1 centimeter we are converting into meters. Now it is 1 by 100. And d hours. Hours we are converting into seconds. 60 into 60. This is 1 by second. This value. So meter square into meter into 1 by second. This will give answer in meter cube per second. If we simplify this equation, you will get 2.778 into A by D. That is how we got Q equilibrium discharge equation. Understood? This itself is a very popular question in GATE exam. Q equilibrium is equal to 2.778 into A by D. Working out equilibrium discharge itself is a very popular question in GATE exam. Let us see. Let us work out 1 or 2 questions related to finding that peak discharge. So this question is asked in ESE exam. ESE 2010 this is. An Esker hydrograph has been obtained for a catchment of 270 kilometers square from a 3-hour unit hydrograph. The equilibrium discharge of Esker. So options given are A 750 meter cube per second, B 277.8 meter cube per second, C 250 meter cube per second, D 187 meter cube per second. So this is how options are given. But find out. Let us see. Solution to this question. So A is given as 270 kilometers square. D is equal to 3 hours. Because 3-hour unit hydrograph is given, with the help of that we have to derive Esker. Okay? Therefore, Q equilibrium is equal to what? 2.778 into A by D. Substitute A in kilometers square, D in hours, then we will get answer. Straight away in meter cube per second. Come on, work out. 2.778 into 270 by 3. So it is 250 meter cube per second. That was the answer for this question. So which option is matching there? Which option is matching? 250 meter cube per second. This is matching, so this is the right answer. So this is how we need to work out. Let us try one more question. Example 5. This question has been asked in GATE exam, GATE question. So last question what he has given is, he has given straight away A value and all. In this question he has not given, neither given A, only D is given. Then how to work out then? A 6-hour unit hydrograph of a catchment is triangular in shape. With a base width of 64 hours, okay, and a P coordinate of 30 meter cube per second. Calculate the equilibrium discharge of an S curve. S curve obtained by using 6-hour unit hydrograph. So last question straight away catchment area is given. In this question catchment area is not given. First of all you need to work out catchment area. How to find out catchment area? It is in the shape of a triangle. 600 hydrograph is in the shape of a triangle with a peak discharge of 30 meter cube per second with a base of 64 hours. Can't work out area, catchment area. We know this. So catchment area represented by this is, how to find out? Volume of runoff by depth of runoff. Volume of runoff means this area of 6-hour unit hydrograph. Because area of unit hydrograph we express, unit hydrograph we use runoff is equal to 1 centimeter. We divide by 10 power 6, try to will get answer in kilometer square. So half into 30 into 64 into 60 into 60 by 1 by 100 by 1 by 10 power 6 kilometer square. This is catchment area A. So D is given. Therefore D is equal to 6 hours. That is known to you. So catchment area is unknown. So that unknown catchment area we can find out indirectly by using the hydrograph. Come on now, how much it is? 0.5 into 30 into 64 into 60 into 60 into 100 by 10 power 6. So it is 345.6. Therefore Q equilibrium is equal to, it is 2.778 into A by D. So substitute area in kilometer square, D in hours. So into 2.778 by 6. So it is 160 meter cube per second. That was the answer for this question. The equilibrium discharge of S curve is how much? It is 160. So options given there are, of course options are given. Of course options are not given. This is a fill in the blanks question. So 160 meter cube per second is the answer for that question. So this is how you can work out the questions. Understood? Hello? Hello guys. Okay then, again we'll see tomorrow. So this offer is closed, I think yesterday only closed, today it is not there, I think, but anyway. Offer closed or not, 30% deduction they are giving. So enroll to free of cost, write all India level exam conducted by an academy. Okay, and cross check where exactly we stand in competition. Use my code GATE Civil. So it's a free of cost only. Okay then.